Hello good day viewers. In this tutorial we are going to use integration by parts to evaluate the integral of sine x cosine x dx. Alright, remember the formula which stated that if you have the integral of u dv is equal to uv, right, minus the integral of v du. So we are going to choose u and dv from our original function, which is sine x cosine x. So I would like to use sine x as u while cosine x dx as dv. It doesn't matter, you can choose either function because they are all of the same category, right? So I would like to let u to be equal to sine x and dv to be equal to cosine x dx. So we differentiate this, we integrate this before we plug them back into this. So du will be equal to, if you differentiate this, you have cosine x dx. Then if you integrate this, you have v. You integrate this, you have sine x. All right, so this is what you need to substitute into this formula. Our formula is the integral of u dv, which is our original function, the integral of u, which is sine x, dv, which is cosine x dx, equal to u multiplied by v. This is u, this is v, sine x times sine x, which I can write as sine squared x. Then you subtract the integral of v du. This is v, this is du. It means sine x multiplied by cosine x dx. Sine x cosine x dx. Again, we need to integrate this, but the more you integrate it, the more it repeats, because it is exactly what we have started with. Can you see that? So the more you integrate this, the more you get it back. So instead, we can bring them to one side. I can take this one to the left hand side. It becomes positive, which makes them to be 2 of this integral of sine x cosine x dx equal to sine squared x. And since this is what we are looking for, we can divide both sides by 2. Finally, the integral of sine x cosine x dx is equal to sine squared x divided by 2. And therefore, the integral of sine x cosine x dx is nothing but sine squared x divided by 2.